So buckle up as we explore how tiny molecules and pathways in our brains can have big impacts. Let's start with attention deficit hyperactivity disorder, or ADHD. It's characterized by inattention, hyperactivity, and impulsivity. Imagine trying to focus in a noisy room. Sometimes your thoughts bounce around like a pinball, and your actions can be a bit impulsive. What's going on behind the scenes? Well, it all ties back to some super tiny messengers called neurotransmitters, like dopamine and norepinephrine, which help transmit signals across the brain's neural highways. In ADHD, these neurotransmitter systems can be a bit out of whack, sometimes too hyper, sometimes too hypoactive. Think of dopamine and norepinephrine as the brain's energizers and focus boosters. When they're not working right, it's like the traffic lights are all out. Some signals get through too fast, others too slow. This affects our cognition processing speed, motor planning, and importantly the prefrontal cortex, the brain's control tower for attention and decision making. Our brain's chemistry doesn't just depend on neurotransmitters. There's a whole metabolic pathway involving tryptophan, an amino acid you might know as part of your turkey dinner. Tryptophan doesn't just turn into serotonin, but also dives into the kynurenine pathway, a complex route where it gets degraded into various metabolites. Think of this pathway as a busy highway with many exits, leading to different substances that can be either neuroprotective or neurotoxic. One of the key players here is kynurenine itself, which can be converted into several compounds like kynureninic acid and quinolinic acid. Kynureninic acid acts like a friendly gatekeeper, blocking certain glutamate receptors and offering neuroprotection, kind of like a bouncer at a club keeping out troublemakers. On the flip side, quinolinic acid can be excitotoxic. It overactivates glutamate receptors, leading to oxidative stress and potential nerve damage. It's like revving your car engine too hard until something burns out. This balance is crucial because glutamate is the brain's main excitatory neurotransmitter, involved in learning, memory, and overall brain communication. Too much glutamate activity, especially from quinolinic acid, can cause damage, while too little can hamper brain function. The pathway's regulation involves many enzymes like endoleamine 2,3-dioxygenase, which kicks off the process of kynureninase, which helps break down kynurenine into other metabolites. All these molecules and pathways are intricately connected across the blood-brain barrier, where peripheral enzymes and amino acid transporters regulate what gets into the brain. So next time you think about ADHD or brain health, remember it's not just about getting focused or calming down, it's about a complex, finely tuned orchestra of molecules, dopamine, norepinephrine, serotonin, glutamate, kynurenine, metabolites, that work together, sometimes harmoniously as studs with a bit of discord. Thanks for joining this mini neurochemistry adventure. Stay curious.